Hello, good morning. My name is Nishant Sawan, and my topic is Eco-State Network and Support Vector Machine Hybrid Architecture for Free Text Keystroke Authentication, which is a novel approach which combines two of the machine learning models. So, keystroke dynamics is a behavioral biometric method that identifies users by how they type, not what they type, and which achieves an error equal rate of 2.63% and 47% improvement over the baseline. Um, it keystroke dynamics provides non-intrusiveness, continuous verification, and it can extract unique signatures from the typing patterns, and because of its growing importance. So the research question was we can achieve how we can achieve better accuracy when using echo-state network and support vector machine hybrid model. And these are the core temporal features for keystroke dynamics, and we have used these core temporal features to train our model and not manual engineering and make many features for the model. We have just used the basic features. Um, so the current approaches in keystroke dynamics are traditional machine learning and deep learning, among which SVM support vector machine excels at finding optimal boundaries, but it is weak to detect temporal patterns. Also, XGBoost, which achieved a 93.79% accuracy for fixed text, but was not able to adapt to natural typing variability. Also, deep learning approaches are not computationally supportive and efficient, and these also require hyper parameter tuning. But among these, echo state networks are good because they have natural temporal capabilities and which makes them suitable for keystroke dynamics. The current limitations in keystroke dynamics are typing variation, data scarcity, um, and model interpretability, which means that we cannot understand, or deep learning models are difficult to understand as compared to machine learning models. Also, transition from fixed text to free text face difficulties because free text has greater typing variability. So this is the eco-state network and support vector machine hybrid architecture, which compromises of these following things, which includes data pre-processing, extracting temporal features from eco-state network, and classifying by using support vector machine, and authenticating users through multi-factor verification. So the advantage is that EcoState network requires no feature engineering. Only the 5 core temporal features are enough because EcoState network has natural temporal capabilities, and it provides practical improvements in authentication accuracy. So these are the configuration, among which configuration 3 was selected for the baseline implementation. And these are the configuration for EcoState network and support vector machine hybrid architecture, among which configuration 4 selected based on the robustness. So for evaluation, we have used error equal rate, which is the operating point where false match rate equals to false non-match rate, and false match rate is the percentage of imposter that attempts falsely, and false non-match rate is the percentage of genuine user falsely rejected. Also, we have used ROC curve for analysis, And the validation strategy includes data augmentation and injecting noise in the typing pattern. Also, we have used statistical significance testing with paired t-test. So the system includes a multi-layer security, which includes these parameters and security measures, which is confidence score, which is dependent on support vector machine, cosine similarity, uh, which which identifies pattern similarity, and Euclidean distance for measuring distance between feature vectors, and the confidence score. If a user falls falls below this confidence score, then it is rejected. Also, the SVM threshold, which is for suspicious score. It also has drift detection with gibberish detection system. For the implementation, we have used hybrid model for implementing it into a graphical user interface, uh, which includes these technical implementations and tools. So, EcoState network performed okay when it comes to baseline. As you can see, there's values, validation values, also the Euclidean distance and the ROC curves. So hybrid architecture uses these configuration, among which configuration 4 was selected because it was robust for validation set. And hybrid architecture has these results, which includes 2.63, which is a 47% improvement over the baseline, and includes these F1 score, AUC, and the score distribution. So the simulation results are false non-match rate, which is 1.32%, false non-match rate, which is 1.32%, and false match rate, which is 2.63, and EER of 2.63, which is same as the hybrid model. So the comparative analysis of the hybrid model of our hybrid model, which is compared to the existing approach. As you can see, our method lies third when compared to other deep learning and hybrid models, which only uses 500 keystrokes and only the basic 5 core temporal features, while being computationally efficient. So the future work, so the conclusion on future work is that this hybrid architecture achieved a 2.63 error equal rate, which surpasses the 5% um, threshold, and it demonstrates that reservoir computing, which is uh, which is a concept of eco-state network, um, is effective when when capturing core temporal features, and SVM is effective for classification. Also, the advantages are that it is computationally efficient and it requires minimal data, also works efficiently with core temporal features. The limitations is that it is the reservoir optimization was limited to 1800 neurons, due to computational resources, and the evolution considered only the desktop keyboard interactions, not any touch or smartphone detection or smartphone or smartphone, and the gibberish mechanism is based on static English dictionary, not bilingual. So the future research would be to combine various machine learning models with ESN and to check its accuracy uh, and perform various attacks on the model to check its robustness. Also, we can extend this model to mobile and touch-based devices. So this is the artifact demo artifact, which includes data cleaning, loading, data analysis, and timing feature validation. Also, this is for checking data integrity and cleaning, initial cleaning, detecting timing intervals, and correcting that, and checking temporal relationships and correcting it. We have performed user disjoint split. Uh, we have split data um, in 60 uh, and 60 for and 60 users for training to 19 for validation and 19 for test. And the features we have used are existing features which can be seen in Keyrex dataset. This is the code for baseline, and this are the results. This is the code for EcoState network and support vector hybrid machine, and this is the user separation. These are the templates, and it describes how a user template is separated. How a user template is separated. So we are gonna see and test our demo. I'm gonna enter my ID and check. I'm gonna include some random characters just to see. Yes, after even including the random characters, it was accepting me. That means it is calculating temporal features. Let's see if the system accepts me with when I am the imposter for another for the user, the real user. As you can see, I am rejected. So let's see in the audit logs why I am rejected. So these are the logs. I was rejected because the pattern my pattern was not similar. As you can see here, uh, that I got these scores, and these are the baseline scores that are for that user. So I need to achieve these baseline scores, and only then I can be authenticated. So this is the audit log. Also, you can create a profile if you want and type freely.